Hello everyone, welcome to 10.2, use of property tangents. Today we'll be starting a new section in our lessons. Hopefully you guys did wonderful on your last test on circles, areas, sectors, circumference, arc lengths, all that fun stuff. But now we're going to go into the other properties of circles. And we're going to start with the property of tangents. So the goal of today is to understand the different parts of circles, know what chords, tangents, and secants actually are, understand the difference of tangent rules, understand the different secant rules they have, and determine what properties tangent have when used in conjunction with circles. All right, so after today you'll be able to understand all these facts and a couple more. So once again, as I said before, when I point to you guys, you try to tell me, see my pointer, what you think the definition is, and then I'll tell you. So first off, what is a circle? All right, hopefully you said it's a set of points that is equidistant. Equidistant means the same distance. So it's a set of points, the same distance from where? From one point, from a given point. All right? So you have one point, and then every other point is the same exact distance from that point. So these are just an infinite number of points right here that make up a enclosed circle. All right? These are the parts of a circle. So first off, what do you think the center is? If you said it's the point, so center is a point, and if you said that's the point that's equidistant, that is indeed the point that's equidistant from all the points on a circle. So if these are all the points on the circle the center is, in the center, or the point that is the same distance. So that means any space I go out, anytime I go out, it's the same exact distance from this center point. All right? Next, what is the radius? You guys remember what the radius is? We went over it last lessons. You should have said it's the segment. So it's a segment, meaning it has two endpoints from the, where do you think it comes from? The center, and it goes to any other point of a circle. So for instance, this is a radius, 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 and all the radiuses in a circle, or the radii in a circle, have the same length. All right? So chord, this one's a little different. Do you remember what chord is? Yell at something. Let's see if you got it. Chord is a segment, so once again it's a segment, but the endpoints aren't in the center. Where do you think they lie? They both lie in the same place, but in different places. That would be on the circle. So do you think you know how you would draw that? Like this, circle to circle. So you can go circle, 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 circle. Can you cross to the center? Of course you can. It's just 2 points on the same thing. Can it be in the same points? No, because then you wouldn't have a segment. Diameter. Use some words we already used to do diameter, and go. All right, so it's a chord because diameter touches both pieces of a circle. But where does it pass through? If you said the center, you were correct. So it passes through the center. So it's just on both sides and it passes to the center. Once again, you can have an infinite number of diameters. They're all the same. And as we discussed last time, the diameter is twice as big as a radius, because technically a radius and a radius. All right. Next one is a secant. This is going to be used all the way through calculus, this one. You think you know what it is? It is a line, and it intersects the circle. It can also be a segment or a ray, but it intersects the circle. Where do you think it intersects the circle? At 2 points. 2 points. So what does that mean? Segments stop when they get to the edge of the circle. Secants can actually run through the circle. All right? So see how it hits it at 2 points? But the line keeps on going on forever and forever. Now, if you had a point here and it went straight through the circle as well, that's okay. A chord really isn't a secant, though, because it has to be on the outside of the circle as well. So tangent. What's a tangent? A line that intersects the circle at not 2 points, but 1 point. So come here, you're just hitting the line at 1 point. So it could go all the way around. And this is actually used a lot in calculus when you are finding slopes of curves. All right? Interesting fact right there. Also, a tangent line is really the slope of a function. All stuff you learned in 3 years. Let's see if you remember that. All right, so anyway, tell whether the line, ray, or segment describe the radius, chord, diameter, segment, secant, tangent of circle C. So what I would like you guys to do is I would like you to take these letters and tell what they are. Go. And then I'll go over them all. So, and now I'm going to go over them. So hopefully pause. BC. B to C is this one right here. And that you should have said is a radius because C is in the center and B is a point on the circle. EA is A. So EA, and what you see over it is the line symbol. So line EA hits the circle at secant because it intersects the circle at how many points? 2 points. All right. DE, line DE. See the line above that? Segment line. So line DE hits the circle at 1 point, so it is a tangent because it is a line that intersects the circle at, as I just said, 1 point. All right. AF, and since there's a segment above it, it's segment AF. So from A to F, now the difference between this AF and this AE, even though they're part of the same thing, AE is the line, so it has lines. AF is a segment, so it's just from here to here. So that means that it is a chord because it intersects the circle at 2 points. Just like a secant, but it stays inside the circle. Segment AB. What's that? That's also a chord, but it's also a diameter because C is the center and it passes through it, and A and B are points on the circle. All right, so hopefully you got all these and you understand the vocabulary involved. All right, that's very difficult. Now what we're going to do is we're going to move on a little bit. We're going to find the radius. All right, let's see if you remember things from last lessons. Find the radius of circle C if its diameter is 26. So can you find the radius? What'd you get? Is the radius bigger or smaller than diameter? Smaller than. So it's half the diameter. Half of 26 is indeed 13 centimeters. Now find the diameter if the radius is 19. So say this is your circle, if this is 19, the whole thing would be obviously bigger and obviously twice as big. So you're going backwards. 2 times 19 is indeed 38 inches. All right, and then the reason you got inches and centimeters was those are the units given. Example 3, find the lengths and circles of the coordinate plane. So use the diagram to find the given lengths. So first thing, let's find the radius of A. So first thing, most important thing you have to do is you have to look at the units on your graph. Now, this unit says each one of these dashes is 1 unit. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, so on. All right? So now we go over here, we have A. The radius of A is 1, 2, right? 1, 2, 1, 2, 1, 2. You can go in any direction to find it. Now for the diameter, you can either multiply this number by 2 or say, okay, here's the center, 1, 2, 3, 4. And then you got 4, right? So why don't you attempt problem C and D using the big circle B. Now the reason you can tell this is circle A and this is circle B is this right here is your center point, all right? As you can see, A is the same distance away here. B is 1 away from this side, 3 away from this side. That's why this wouldn't be circle B, but this would be circle B because all the radiuses are the same. So what'd you get for the radius? Let's see. You should have gotten 4. 1, 2, 3, 4. Now for the diameter, 1, 2, 3, 4. 1, 2, 3, 4. 2 times 4 should have been 8. All right, easy stuff. This is just like I said before, an introduction into what we're going to be doing now. All right, let's go to problem number 4. I want you guys to do 4 and 5 real quick, and then I will go over it. All right, now time to go over it. Are the following best described as a radius, chord, diameter, secant, or tangent? So, segment AF, 2 sides, goes through the center, so it is a diameter. Line BD intersects 2 points, all right, so it has a chord inside, but since it's a line, it is a, and this one's also a chord, but this one right here is a secant, all right? Segment GC, that's easy, that's a radius, and that's it. And then line HF, line hits in one spot is a tangent, all right? Easy peasy. Find the following radius of C. Uh-oh. Now this, once again, units are 1. Now look what you do here. This is actually in the center, so it's 1, 2, and a half. You can have a half, that's okay. Diameter, 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. All right? 1, 2, 3, 4, 5. If you went diagonal, it'd be 5 too. All right, radius of D. Ooh, look at this little guy. Well, the whole diameter, I would do diameter first. You can see that's 1, so the radius is actually half. And then your diameter is 1. Teeny little thing. You could have teeny circles too. Nice and easy. All right, so for problem number 6 now, what we're going to do is we're going to say how many tangent lines the circles have. Now, if a line is tangent, what does it do? Yell out your answer. Yes, exactly. It hits the circle at one point. Now, each one of these is a different circle, so you can hit each one of these circles at one point or just hit one. Now, how many common tangents? What does the word common mean? It means the same. So what a common tangent does is it hits both circles in one spot. So let's look at A right here. So one line that intersects 2 circles at one point, so it's the same line. So how many lines do you think you could draw that hit both of these circles at exactly one point? Try it real quick. All right, let's see. If that was one of your lines, you're correct. It hits this circle at one point right here, and this circle at one point right here. All right, now if it wasn't, why don't you try to see how many more you can find? If you found this one right here, you were correct. Now, is that the only 2 lines? Can anyone think of any other lines? You could actually shoot right through the center. It hits this circle right here, and it hits this circle right here. So you have 3 common tangent lines. So why don't you try B, C, D, E, and F? Go. All right, let's go over them. What number did you get from here? Yell out your number. Oh, maybe you guys can even hear each other. All right, so you got 1, 2. It's in 2 spots. 1, 2. It's each one in one spot. You can't go through the middle here because then you would hit it twice. That'd be a secant, so your answer is 2. This one, really just that one spot right there. 1. D, this is a tricky one. How many times? 0. Any line you draw through here will hit everything in 2 spots. What about E? This is the one that most people have trouble with. If you got 2, you are halfway right. What about doing a little X to the middle? 1, 1 spot, 1 spot, 1 spot. So answer for E is actually 4. And then F is the last one. You should have gotten 1 and 2. Right? So 3, 2, 1, none's 4, 2. Common tangents. All right, now let's go into some theorems. Theorem 10.1. If a plane is tangent to a circle, if and only if the line is blank to a radius of the circle and the endpoint of the circle. So what are these? What is OP, the radius here, and line M, the tangent line, look like? So a line is tangent to a circle if it is blank to the radius. Ready? Yell the word. Whoa, almost broke my phone. All right, and the word you should have yelled was perpendicular. Very good. So try example number 7. Go fix you. All right, lost my pointer. So example number 7. In the diagram, RS is the radius of R. If ST is tangent to R. So first thing you can do is the converse Pythagorean theorem from chapter 8. Right triangles use the formula. So what does that mean? I'll tell you what it means. What's the formula for a right triangle? C squared equals A squared plus B squared, or A squared plus B squared equals C squared, right? So if the 2 legs squared equals the hypotenuse squared, your answer is a right triangle. Remember, if your 2 legs squared, if your hypotenuse squared is greater than your 2 legs squared, it was obtuse. If your hypotenuse squared was less than your 2 legs squared, it was acute, right? So let's look at this problem right here. First off, how do we find the hypotenuse? The hypotenuse is the longest side, so 10, 24, 26. Longest side here would be 26. Therefore, these are my 2 legs. 26 squared. All right, what does that equal? Put it in a calculator. 10 squared, 24 squared. What do they equal? Put them in calculators. 676, 100, and 576. 576 plus 100 is 676. And what do you notice about the 2? That they are equal. So it's a right triangle. So RS right here is perpendicular to ST. So that means that ST is a tangent to R. Even though it's only a segment here, like I said before, it could be a segment as long as it's external. All right, got it? Not very difficult, is it? Now I want you guys to try problems 8 and 9. Is ST, the purple line, perpendicular, is it tangent to the circle? So in order to find out if it's tangent to the circle, you have to find out if it's perpendicular to the radius. In order to find out if it's perpendicular to the radius, the 2 legs squared have to equal the hypotenuse squared. So go. Problem 8 is a tricky one. And after you figure out how to do it once, you'll be good. I'll give you a hint. 12 is not your hypotenuse. RT is your hypotenuse. But, however, RT does not equal 8. So what does RT equal? Anyone know? You should have said 13. Now, how did I get 13? If this is 8 from this point to T, I still need the point from R to this point. And that is actually 5. The reason that's 5 is the radius here is 5. So the radius here also has to be 5. And 5 plus 8 is 13. See that? So you got to make sure. You have to look to see exactly what is given. If this whole thing was given to you to be 13, you wouldn't have to add the 5. So now we could do our work. 5 squared, 12 squared, 13 squared. So 13 squared is 169, 25, and 144. 169 equals 169. Check. They are equal. That means they're right. That means since it's a right triangle, it means the two sides are perpendicular. And this is stuff you don't have to write down. This is just showing you. And since they're perpendicular, ST is indeed a tangent to circle R. Or you could have just put yes. All right. Right here. Ready? Try it. All right, good. Once again, 7 plus 12, hopefully, is 19. So 19 squared, 12 squared, and 16 squared. 361, 144 in that. Now, these two are not equal. Since they're not equal, it means it's actually not a right triangle. Since it's not a right triangle, it is not tangent to R. This would actually be a, what kind of triangle? Less than acute triangle. Good? Not difficult. Just a bunch of stuff. So this would have been your homework. So let's go over this. I want you guys to match the figures. All right? I want you to list the radius and diameter. Go. All right, let's go over this. B. What do you think that is? It's the point of tangencies, because it's the point that this thing hits in one shot. BH, let's see, BH, line BH. Oh, it hits two circles, but it hits them both at one spot. So it is a common tangent, all right? AB, where's AB? It is segment AB. Since it's a segment, it is a chord. Line AB, same thing, but now it's the line. Since it's a line, it's not longer a chord, it is a secant. Line AE, it hits one circle at one point, therefore it is just a singular tangent. Point G, obviously that's a center. CD, segment C to D, that would be your radius. And segment BD would be a chord, but more importantly, it is a diameter because it passes through center C. All right, so that would be your definition section. What is the radius and diameter of circle C? So first off, radius. Now look at, here's the key, 3, 6, 9. Each one of these things is 3. I bet a couple of you guys didn't see that. So 3, 6, 9. The radius is 9. Diameter, 3, 6, 9, 12, 15, 18. Or 2 times 9 is 18. What are the radius and diameter of circle D? So each one of these is 3, 3, 6. And the diameter is 2 times 6, which is 12. Now draw the common tangent lines to the circle. How many did you have? Hopefully you had 2. You have the top, and you have top and the bottom. All right. Any questions with 1 through 11 from the homework? All right. 12 through 17. Finish up these homework problems. But I had a bunch. So draw the common line, tangent line, say how many they have. So first one, number 12. You should have gotten 1, 2, and then the crisscross, 3, 4. All right. Problem 13. You should have had 4. You got to go that way, Ryan. 0. And for problem 14, you should have had 1. Go around that way. For problem 15. All right, hold on one second. Yeah.
I want to go home.
Now, problem 15 should have had 5 squared equals 3 squared plus 4 squared. 25 is 9 plus 16. 25 equals 25, and that is your answer. Since that is a right triangle, that is tangent. This one right here You have your 18 squared. It gives you the whole thing, not just part. All right, they do not equal each other, not a right triangle, so it is not tangent. Okay, tangent is a check, not tangent is an X. Right here, 48, 52. Now, this is weird. What do you think? 52, you need the right angle to be here. Numbers are not equal anyway, so it is not a right triangle. All right, good. Any questions? Let's go on to the next one, example 10. We're just going to continue through these things. In the diagram, B is the point of tangency. Find the radius R. How do you think you do this? You have to use your Pythagorean theorem. So, what is, you need to be a right triangle, so you can use the converse Pythagorean theorem. So, A squared, AC squared. So, our hypotenuse is AC. So, what does AC equal? Doesn't equal 49, doesn't equal R. It equals, we're going to use the Pythagorean theorem, 49 plus R. You combine the two. What is BC? R. What is AB? 77. So, hopefully you guys remember how to FOIL. 49 plus R squared equals, you remember how to do this? Everyone should. It is FOIL. First, inner, outer, last. So technically you're multiplying 49 plus R times 49 plus R. 49 times 49 is 2,401. 49 times R is 49R. 49R, add them together, you get 98R. R times R is R squared. So that's what this equals. R squared is just R squared. 77 squared is 5,929. Now look what happens here. We have to solve for R. So if we subtract R squared from both sides, they just cancel out. You could do that. Now you subtract 2,401 from both sides. You get 98R equals 3,528. Divide both sides by 98, and you get 36. And that's what our radius is. 36, 36. If you added 36 plus 49, 85 squared equals 77 squared plus 36 squared. It'd come out normal. Got it? Excellent. Let's look at a bonus lesson. Now, this is a bonus lesson mainly because a lot of students in the previous years had trouble foiling. So let's look at this again with the FOIL. So FOIL, first, outer, inner, last. So first is multiply the first two. 4x times 3x. All right, is 12x squared. Outer is the two outside numbers. So 4x times negative 2. That's negative 8x. Inner is the two inside numbers. I think my colors are bad here. Yeah. It's 5 times 3x, which is 15x. Last are the two last numbers. So that's 5 and negative 2. For some reason, these don't color. 5 times negative 2 is negative 10. All right. So what you do is negative 12x minus 8x. You combine like terms. Typically, you combine the two in the middle. The ones on the outside, your first and your last, stay because there's not common terms. Negative 8 plus 15 is combined to give you 7x, and that's your answer. So why don't you guys attempt problems A and B? Go. All right, going over these in my bonus lesson. First is 2x times 3x. Outer, 2x times negative 5. Inner, 7 times 3x. Last, 7 times negative 5. 6x squared, negative 10x, 21x, and 35x. Inside things are the ones you combined. 21 minus 10 is 11x. And there's your answer. See? 10 from B. All right, let's look. Negative 6 times x first. All right. Outer. Inner. Last. All right. 6x squared minus 54x minus 3x minus 27. 54 negative 3 is minus 57. Negative 6x squared minus 57x minus 12. Good? Awesome. All right, let's go over two more theorems. That's really not part of the lesson. It's just reteaching you guys how to FOIL. Tangent segments from a common external point are blank. They're congruent. So what that means is RS equals ST, or the length of RS equals the length of ST. RS is congruent to ST. So let's use this in a theorem. We want to find out what x equals here. So what we do is we set these two equal to each other. 3x plus 5. Oh, where am I at? Oh, what have I got here? Oh, the reason they're congruent, sorry, is because you have two radiuses that are equal. You have a common point right here that are equal, right? So that's side. That's side. What else do we got here? And then we got the right angles because they're tangents, right? So this is a side-side angle. Nope, this is HL. Remember HL congruence? There you go. So that's just the reason why they're congruent. All right, sorry. Let's get back down to down here. These two pieces are congruent because they're tangents. 3x plus 5 equals 32. Subtract 5 from both sides. Divide both sides by 3 to get x equals 9. And that's it. So why don't you try problems 12 and 13? 12 is different. 12 is like we did originally, the harder one, and then 13 is like the one we just did. All right, this one you have to see if this is a right angle. So you want to see if LJ, the hypotenuse, squared is equal to both legs squared. Hypotenuse squared is r plus 32 squared. Does that indeed equal r squared plus 56 squared? All right, when you FOIL that, you're doing r times r is r squared, r times 32 is 32r, 32r is 64r, 32 squared is 1024. All right, cancel out the r squareds. Subtract 1024, you got 64r equals 2112, and you divide both sides by 64 to get 33. Good? Awesome. Problem 13. If they're tangent, they're equal. So x squared equals 49. How do you find what x is? You have to take the square root. And it's actually positive or negative 7. Because negative 7 squared is 49. Positive 7 squared is also 49. Anytime you have x squared equals a number, that number is always going to be plus minus. Got it? Awesome. All right, so I want you guys to finish up with these last homeworks. Okay, 1 second. Now, 2 minutes of that for Now, problem number 1. So, first thing you should have done, right here, add these two together to get r plus 16. All right. These you should have added together to get r plus 6. All right. Just two things. So r plus 16 squared should have been r squared plus 24 squared. You FOIL this. R squared plus 16r plus 16r is 32r equals 256. Another formula for this is you square the first number, you multiply this times 2, and you square this. That's just a formula. A plus b squared equals a squared plus 2ab plus b squared equals r squared plus 576. You cancel out an r squared from both sides. You subtract 256. 32r equals 320. R equals 10. Very good. R plus 6 squared equals r squared plus 9 squared. R squared plus 12r plus 36. Right, there you go. See, little trick. Or you can just expand it. R plus 6 times r plus 6. R squared plus 81. Cancel out the r squareds. Subtract the 36. You get 12r is 45. R is 3.75. Divide by 12. And this one, they're both equal. 3x plus 10. Oh, my red got messed up. Equals 7x minus 6. 4x minus 6 equals 10 because I subtracted 3x from both sides. Add the 6 to both sides and divide by 4 to get x equals 4. All right, and that's it. Hopefully you guys did well in this lesson. Weren't too distracted, and good job. See you next time.